71. Gosh, who assigned something so high as a 71? Ay, caramba. Mean old math teachers. Okay, so you're working 2 jobs, right? Okay, so in your first job, you're working 25 hours at $7.75 per hour, right? Your second job, you're working who knows how many hours at $6.25 an hour, right? You want to make $250 because you're not greedy. Okay? Right? So I would say here that X then is going to be equal to the number of hours worked. Right? Okay? So you take this money and add it to this money, and you want this money. Right? Okay? So 25 hours at $7.75 per hour plus X hours at $6.25 per hour is going to equal $250. Okay? All right? So then that tells me that 193.75 plus 6.25x equals 250. Okay? Subtracting 193.75, 193.75 gives me 6.25x equals 56.25, dividing by 6.25 on both sides, then would give me x equals 9. But that is 9 hours. Okay. Somebody else back here had a question. Yes, ma'am. 47. Ooh, I like it. Oops, I should have went back here and I should have said that this was number 71, I think is what we said this was. And then this one down here is number 47. So 3/7 W minus 2/9 is equal to 4/9 W plus 1/7. Can I ask you a personal type question? Are you a fan of fractions? Okay, so let's get rid of them then. Right? So what are you going to multiply by? Okay, so what's common between 7, 9, 9, and 7? 63. So I'm going to multiply the whole entire equation by 63. Okay? So that means that that one is going to be multiplied by 63, right? Now, what's 63 divided by 7? 9, right? And what's 9 times 3? 27, I like better. Okay? And then 63 has to be multiplied by that one. What's 63 divided by 9? Times 2. 14. Yep. And then 63's got to be multiplied there. You already said 63 divided by 9 was 7. 7 times 4 is 28. And then 63's got to be multiplied there. 63 divided by 7 is 9. With me? Okay. So now then I would subtract 27W. And at the same time, I would also subtract 9. So that gives me negative 23 equals W. Yes, ma'am. 16. So, did you get it to 3/11 B equals 0? Yeah? Okay. So, because you started with 3/11 B plus 5 equals 5. So, when I subtract 5 from both sides, I'm left with 3/11 B equals 0, right? Right away? So you multiply by 11? Okay, so that's fine. So if you multiply by 11, then that would be 3B plus 55 equals 55. Because you got to multiply everywhere by 11 then. Okay? Either way, so now here, if I divide by 3/11, 0 divided by anything is 0. Over there, if I would go subtract 55, then I'd have 3B equals 0, and then divide by 3, I'd still get B equals 0. Okay? That one was tricky because that whole equals 0 part. Yes, sir.
So that'd be no solution or just
0. 0 is a number. Yep. It'd be no solution if the B went away. Okay? If the variable goes away, then it's that infinite solution, no solution case. But because the B is still there, 0 is a number. Okay? Okay. This will be the last one because then we got to roll. So 18 is 3 plus 8/7 D equals -1. Right? Okay. Subtract 3 from both sides. Yes? So then that is 8/7 D, or I should, before I even did that, did you multiply through by 7 first? Or not? You did? Okay. So if you multiplied through by 7, you would have gotten 21 plus 8D equals -7. Okay. Here then, I would multiply both sides by 7. And then divide both sides by 8. Fantastic. Okay, so my goal today is to solve all of life's problems. Okay? Hey, you want to talk sometime, sister? We'll talk. I'll solve all your problems. You may not like the solutions, okay? But I will solve all of life's problems. Okay? All right, here we go. Here's how you solve all of life's problems. First, you got to read. Okay? Reading is good. Okay? Then, in math, we're going to be doing word problems today again. Okay? Which was kind of good that you asked about that word problem, because we're going to be doing stuff like that today too. Okay? So, got to read it. Then, sometimes you'll be given an equation to use. Sometimes you got to make your own equation. Okay? So sometimes people do stuff for you. Sometimes you got to do stuff for yourself. Okay? Then you solve it. Okay? You put your plan into work. Okay? You plan your work, like earlier today in pre-calc, we were planning our work, and then we worked our plan. Okay? And then, lastly, especially in word problems, does this answer make sense? What I mean by that is, if you're solving for time, let's say, and you get a negative answer, what does that really mean? If you have a negative answer in terms of time, you're going back in time. Which, unless you got a flux capacitor in 1.21 gigawatts, pretty sure that ain't happening. Okay?
I've seen the movie.
Okay, good. We'll be referencing a couple of movies today.
Oh,
Okay. Alright? If it was like a number of people going into a movie theater type problem, and you got 109.09. Does that make sense? Not really. Okay? Because it's very hard to make 0.09 of a person. Okay? Right? Unless you're like taking off 3 fingers and just walking those 3 fingers in. You know? Get your popcorn. Okay? Okay? So, logic helps out. Okay? When you're using formulas, sometimes the formulas will be given to you. When you're using formulas, I like to write out the formula first, like without anything else. Just write out the formula. And then go back and put stuff into the formula and then solve it from there. Okay? That's just me. Again, I'm crazy. Okay? Certifiable in some cases. Okay? OCD in the others. So, distance equals rate times time. Okay? D equals R times T. Okay? I'm sure that you've probably seen it at some point in time. How far you go is dependent on how fast you are going and how long you are going for. Okay? So, distance is equal to rate times time. So, if it says find the missing variable, D equals 300 miles, R equals, we'll put a big old question mark there. And T equals 4 hours. Okay? So, I would again start with the formula. D equals R times T. We know that D is 300. I don't know what R is. And I know that T, is 4. So 300 equals R times 4. How are we going to solve that? Divide both sides by 4. So we get 75 equals R, right? But can we go even more in depth into that 75? Miles per hour. So either 75 mph or 75 mi/hr, or actually write out miles per hour. But yes, labeling our answers is phenomenal. Okay. Casey and the Sunshine Band once sang the song. Cool in the Gang. Celebrate good times. Come on, that's Casey and the Sunshine. Cool in the Gang is an actual group. Okay. So we cool in the gang? There it is. Okay. So, Matt Kenseth, who is Mrs. Linsmeyer's favorite NASCAR driver, since he's from Wisconsin, okay, raced 600 miles at Charlotte, North Carolina in 3.5 hours. What was his average speed? Find it for me. Because I want to go fast. Name that movie, Lexi.
What?
I want to go fast.
It's not like first.
Nope.
I don't remember.
Days of Thunder is Robbins Racing. Ricky Bobby. Ricky Bobby is the correct answer.
Now, again, what I said, who wants to go fast? Anybody? I want to go fast.
I want to go fast.
Oh, yeah, I don't think I've ever seen that movie. Shucks.
So, start again with D equals R times T. So, my 600 miles is the distance. Don't know the rate? Time. 3.5 hours. Okay. Divide both sides by 3.5. So, help me out here. 171 point what? 43. Okay. Go out to 2. 43, and that's going to again be miles per hour. Is going to be his rate. Okay. On a test or a quiz, I'll tell you what I want it rounded to. How many decimal places? Okay. Good. I'm going to give you 7 minutes to struggle with this problem. Okay? All right. So, you are hanging 3 pictures on a wall in your home that is 16 feet wide. Okay? The widths of the 3 pictures are 2 feet, 3 feet, and 4 feet. You want the space between the pictures to be the same, and for the spaces to the left and right of the group of pictures to each be 6 inches more than in between the pictures. How should you position the pictures? Okay. All right. So, one thing that we know is that the wall is a grand total of 16 feet wide. Right? Okay. What else do we know? Okay, what are the size of the pictures?
I'm assuming the biggest one's the 4-foot one.
Okay, does it have to be though? Could they be in any order?
Probably.
They could be in any order, but just for, so we'll say that this one is the 4-footer.
The one is 3 feet and the one is 2 feet.
So that's this stuff. Took care of those. Okay. We want the space between the pictures to be the same. So what do we want that to be? What do we want it to be? Do we know what it is? No. So what do we want it to be? I can't make it be 6 inches. Because I don't know what it is. If I know it's going to be 6 inches, then I can put 6 inches and then we're done with the problem. We want it to be what? X. I want it to be X. Because I don't know what it is. So then we should probably define what X is. So X is the space between the frames. Okay? One last piece of information is that one right there. The space to the left and the right needs to be 6 more inches. So how am I going to put that on my diagram? What? 6 plus X. Do we agree with 6 plus X? Okay. In parentheses, 6 plus X. Is that what goes here? Whoa, now we're talking 0.5. Where are you getting 0.5 out of 6? Because every other dimension that we have up here is in feet. Okay? 6 inches is not in feet. So this over here should be X plus 0.5. And then over here should be X plus 0.5. Okay? One of the ways that I knew that you were wrong is there wasn't a 6-inch difference between your two. Because didn't you say 9 and 12?
Yeah, but like.
So then there's not a 6-inch difference.
Oh wait, I think I'm
With me?
Yeah.
Okay. So now we got to come up with an equation out of this scenario. What equation can we come up with? Need to come up with an equation. Two x. Where did you get the 2x from?
The 2 spaces in between.
Okay, so I used up that space and I used up that space. Okay? Plus 2 parentheses x plus 0.5. That's this one and that one.
Equals 16.
No. Plus 2 plus 3 plus 4. 2, 3, 4. Equals 16. Okay? So that gives me 2x plus 2x plus 1. We'll add those all together right away. That's 9 is 16. So that's 4x plus 10 is 16. So that's 4x is 6. So that's x is 3/2. Do I like 3/2 feet? What do I like instead? 1.5 feet. Okay? So that tells me that there is 1.5 feet where? Between the pictures. What's the other dimension that I need? Between the wall and the first picture, right? So on the left and the right side. So how many feet are on the outsides? 2 feet. Yep. Okay. And now we can position our pictures. Table shows the height h of a paramotorist after t minutes. Write an equation to model this situation. So basically what I am looking for here is I am looking for h of t. Find me h of t. Did you notice anything about the chart? What? It's linear? Do we agree with that it's linear? How do we know that it's linear? What? It's always going down by 250 every minute. So every minute it's going down by 250. And that's constant, so therefore it's linear. Okay? Alright, so we need to come up with a line, a linear equation. So that's going to be like something, some rate of change times t in this case, plus some constant. Okay? So, what do we come up with for the equation of this function? What do you got, Tim? Close. You're missing a key thing, and you got the wrong letter. Alright? Ready? Negative 250, because we're going down. Yours, Tim, would have if we were going up. Okay? So you were working right to left when we were working left to right. Okay? So I would agree with here of negative 250 t, because that's the variable that we had defined, plus 2,000. Now, what if I wrote that as 2,000 minus 250t? Is that okay? Yeah. Same thing. Yeah, exact same. Okay. So, tonight, your homework is this. It is only 9 problems. Okay? So, totally doable. For tomorrow. Don't forget that Monday, a week from today, you will have a chapter test. on chapter 1.